to start, so Ethereum and IoT workshop. Streamr is a platform for real-time data. And what we mean by real-time data is basically you can think of an API where you post JSON messages, and those JSON messages are data points. And this stream of data points is this real-time data stream. And it is not in the format of the data that makes it real-time, but it's more like in the value of the data, right? So we like to say that real-time data carries a value that must be extracted before it expires. I'm not sure if that used to be a motto. It's a lousy motto because it's too long. But that's the idea of real-time data. It's something that's valuable now and not necessarily next week. So that's a Streamr platform. It was originally developed for algorithmic trading, actually. So that's where the sort of speed of information is pretty essential, and that's something we are aiming, or we are sort of working on to bring to the smart contract and DApp ecosystem as well. Right. So IoT is an example of real-time information, sensors measuring things, locations, temperatures. They are generally valuable now and less interesting next week. But I mean, it might be, but usually you want to sort of automate the sort of response to whatever weather events and stuff like that. So since this is a workshop, very hands-on, I'm going to just try to figure out who we have here. So out of those who brought their laptop, how many of you have programmed smart contracts before? So written smart contracts, okay. And how many of you have not and would like to? Okay, because I mean, good. So maybe those who are interested in that part specifically, I would suggest you move to the front so that we can have really like hands-on experience with you guys. Because I mean, well, moving to the next slide maybe. Or maybe not. How does this work? Okay. So myself. Okay. So I've been hosting this sort of Ethereum workshops for a year now. Well, I'm a developer. That's my job, but roughly once a month. And they are really starting from zero kind of things, which is not maybe so fit for this Web3 thing. So we're going to do this starting from scratch thing very fast. In the meantime, those who already are familiar with smart contract development could open up streamr.com and register and make an account. And yeah, I could actually show quickly like the Streamr. When after you log in, you get into this kind of we call it canvas, where you build these data processes or data automations. You have Stream, which is now these IoT sensors over here producing data, and then this data will hopefully end up by the end of this workshop into the Ethereum network. But what we have here is that when you sign up and log in for the first time, you will start this kind of tour. So this will be necessarily split into two now, I'm afraid. So those who are already familiar with smart contract development should maybe start by doing one of these tours. And we are here to help with those. So they go really step by step. Building this kind of simple canvas thing, and they basically go through the Streamr tool. So that's kind of something for you guys who already know the Ethereum side to get familiar with Streamr. So and the tour should start automatically on the first login, but it's underneath a question mark. There's like the first and the second at least are probably good introduction to what Streamr is, if that's what you would be interested in. And hopefully we will tie this together when we have the smart contract part done by then Waylay introducing the Raspberry Pi and sensor setup so that we can get everybody producing data and so on.
Yeah. Maybe you want to show them quickly the canvas, transport canvas I have there, just to show them like.
Well, I think the tour goes through building a canvas. So
yeah, I'm saying like just to show them transport.
Okay. Yeah. So well, okay. Another fancy canvas. So there's like this MQTT stream of vehicle locations, and you can see those vehicles moving. It auto zooms out, I guess, when they move. And here you can see the data ticking in pretty rapidly. So this is basically the Streamr promise that this is something you cannot just stuff into the blockchain. It doesn't work like that. So what you would do is instead aggregate it somehow. Like here, there's moving average of vehicle speeds being taken, for instance, and perhaps this could be put in the smart contract like once in 10 minutes or something like that. Perhaps from the vehicle speeds you could aggregate, this is kind of the scenario that this demo demonstrates, that perhaps there is some traffic operator that runs the traffic for this city and then gets paid by each kilometer these trams drive. And you would aggregate the number of kilometers the trams collectively drive, and then it would sort of pay it out in the smart contract every now and then. This is sort of the first demo that we presented in DevCon, EdCon in 2017. But so that's kind of like where we started from. But yeah, so it's kind of like a use case for smart contracts and for then this streaming data. Right. So for those who want to start with the smart contract development, please. Which browser do you have? Do you have Chrome or Firefox? At least Chrome.
Yeah, Chrome.
Okay. So go to MetaMask.io and install MetaMask plugin. That's the first thing. And well, I mean, I guess we more or less. I guess Waylay could introduce himself as well.
Yeah. Hi everyone. Well, as you saw, I'm most of the time managing the developer community outreach. I mean, like we can host like hackathon, have small teams and individuals to work with the Streamr technology stack, do some integration pilots. We do have a partnership team that does like large scale, of course, like partnership. But for anyone that's interested in IoT, Ethereum, or like real-time data network stuff, feel free to reach out. And we have a lot of community members doing some integration. For example, one of them is Fitbit sense integration, which will go into our what is called a community bundling stream. Right, that will be like a new product we'll be launching. So I'll be around if you want to learn more about Streamr, the technology that we're using, or like how you can get involved or contribute.
Yes, and Waylay will be after everybody who already knows how to program smart contracts is familiar with Streamr, and smart contract programmers are on board as well. Then Waylay will help everybody with sensors to get the sensor data in. So yeah, this is something I already went through more or less. We have the data marketplace as well for buying and selling those data streams. It's like an application built on top of the Streamr network. So that's basically the platform. Great. And today, connecting sensors to blockchain. So this would start with the Ethereum and token deployment. I've written 20 minutes. It's ambitious, but let's see how far we go. So, was there somebody else who wanted to get familiar with the smart contract development who hasn't done that before? So, okay, yeah. Well, you can come here if you don't have a laptop. It's fine. Yeah, it's fine. Yeah, you can sit next to a friend. it's actually a good way to work. Yeah, and have you got MetaMask installed?
Yeah.
Okay, good. And then if you could open this Google Sheet. Why Google Sheet? Well, because it could be some Slack or Telegram or whatever, but those are actually pretty good collaborative things as well, if everybody behaves. But so if I open it like this, I will get this kind of worksheet where you can open, if you open the Fox like this and click on the account, try to find that.
Can you show the link again?
Yes, absolutely. So the link I will write here. So it's Google.
Well, I use the back account.
Oh yeah. I'm not sure. I guess it's almost visible. So Google. Almost. So yeah, this is the sort of worksheet and these workshops that I've hosted before, like starting from scratch, it is actually part of this kind of Ethereum evangelism, if you like. So going to universities, also companies. I mean, universities for free, and companies I've taken some token fee of maybe 1,000 euro for 1 day workshop. So so yeah, it's been fun for myself, but I mean, above all, of course, I'm sort of it is part of this promoting Ethereum work. Hopefully, I think last I did it in Mexico, in Mexican universities, and it was also cool. So yeah, so after you've got the worksheet open, open the Fox icon you have in your browsers and click on the account. So you can paste your account over here. So then I can send you some testnet ether. I guess this is the fastest way of getting it, at least since we don't have that many participants with the laptop. So so yeah, usually I've also taught people how to get testnet Ethereum from the faucet, but I guess now we can just go with some testnet ether that I already got before. So I'll just send 5 ether, for instance. That's more than enough. Okay, we've got so many participants. Okay, well, who was the 616? So whoever was the 616, the first person. This is also a fun thing to start with Ethereum. That I send some test ether. You could put your name in the after your address. Okay, so Nikolai hopefully got, well, we are running in the Rinkeby, so yeah, I mean Rinkeby is testnet of the Ethereum, and it's quite quite slow, of course, but I mean this gives still the Ethereum experience. So I sent some ether to Nicola now, I think. So I can go and see the transaction in Etherscan by clicking on the Fox, the transaction, and then view on Etherscan, this kind of arrow over here. So no. Let's see again. But yeah, so this is the starting point for Ethereum to get some ether. Let's try again. 5 ether. Okay, there you go. Okay, nonce too low. Fair enough. So there's an old transaction somehow queued up. Awesome. Could be the internet, but well, let's try again with this account. So yeah. So now I sent 2 Ether to Nikolai, and after Nikola gets it, then she or he?
It's me.
Or it's you. You could send it forward to Yannick.
Okay.
But yeah, so the alternative way of getting Ether is there is oh okay, I've got the Kovan faucet address there. Probably
Quick question.
Yeah.
Do we all have to be on the Rinkaby testnet?
Oh, very good point. Very good point. I mean the addresses are the same. That's actually funny with Ethereum, that you've got what an address is in Ethereum. It is essentially a big number, right? So the way you make up new Ethereum accounts, it's super simple. You make up a big number, and then that's your private key, and that becomes your account. But for sure, it's good to select the Rinkeby test network.
Okay.
Let's see if the Rinkeby faucet works. Yeah, I mean, it's kind of painful to use. You have to send a tweet and then paste a tweet link into this thing over here. So I can show how it goes if you want to get the Ether faster that way. So I've got my Twitter alias over here, and then I have sent a tweet with the test account. So I have sent a tweet like that, and with that tweet I copy the URL and then paste that into Faucet Rinkeby IO. I'll paste that address on the worksheet actually. Yeah, I've used Kovan testnet in a previous workshop. I think that at that time the Rinkeby faucet was broken somehow, but it seems to be working now. So I paste the Twitter URL in here and select give me Ether, and then, well, then it will send me Ether at this 3F2 address. And if I look at the 3F2 address, oh, it's this one, yeah, now it got extra ETH. So this is how easy it is to get more Ether in the testnet. Obviously, nobody should be paying what it says here, 7,000 USD for this Ether. Well, I'll try sending one more time. So send to Aeon this time. Let's see how. Just refresh the page if that matters. Actually, just try restarting Chrome if that matters, because okay, lots of things open here. So sometimes the MetaMask does that, I guess. I mean, it gets stuck into, well, some old transaction. So let's see again if the account actually works. So yeah, after we've got the testnet Ether, the well, I mean, are people doing the faucet, or like everybody who has got their coins? Like I'm hoping Nikola has the coins now. So I just color, or they could color themselves with something that indicates that they have the Ether, something like green maybe. No, it's not a very nice color. But anyhow, so one way to see the balances of the addresses is use a block explorer like Etherscan. Let's see if I have the link. Again, I should probably change that block explorer. So block explorers are of course places to check what happens in the blockchain, and it seems that that Nikola has already sent forward Ether. That's great. So yeah, this is what it looks like in the Ethereum network. Of course, to get to the gist, which is developing the contracts themselves, once we Okay, who all has Ether now? Who all thinks they have Ether? Okay, awesome. The next thing we can do is start the Solidity IDE. So after MetaMask is installed, the Solidity IDE should work just magically. And okay, that could be already something fairly complex going on, but let's just close that and start our Solidity introduction. Let's see if I can make it a little bit larger. So I think it's already named like that. Let's call it puzzle. It's a better name. Now it's more puzzling. Right. So so the question is, what does this contract do? And I mean, again, like introduction to a new programming language. I'm sure you have some form of programming experience. So I think it's good to dive right in. And this is fairly I mean, nowadays people trade with tokens and all that. Well, this is still just sending and receiving Ether. But can one of the new people guess what this thing is actually doing? So can you guess, like, so there's the constructor that saves the addresses that are given to it, and then there is a function that when it's called, the question is what does it do? So there is this kind of magic object called message, that you can get some things like the sender of the transaction, and you can get also the Ether that was put into the transaction. So what is that thing doing?
So it splits the value to both of them?
Yep, so it sends half there and half there. Okay, one of more experienced people, can you spot the bug in there? Like, in what way does it perhaps not work as intended?
Safe math.
Well, safe math for sure. So Solidity doesn't support floating point numbers. So if you send in five way, then of course 5 divided by 2 is 2, like everybody knows. And well, since there are no floating point numbers, it will send 2 way forward and keep 1. And that 1 will be frozen there forever. And that is also a fun. Let's just say that. From a bit maybe earlier times, nowadays people are more aware of the lockup thing, but since it's a contract that is immutable in the Ethereum chain, it will keep that 1 because it has no facility to get that 1 way out of there. Well, later, of course, I've been thinking a bit more about this example. That yeah, sure, you could check that if that thing is divisible by 2 and then send the extra way away or whatever. But then again, with gas costs around gigaway, the check itself would cost several billion times of the fund that actually get locked in there. So this is still a correct solution, even though of course it is a bug in the design that sometimes the round of error gets stuck in there. Okay, well. Has everyone do you people did you get the remix open still? Yep. So the next thing, well, you can deploy the puzzle over here. I think there was a link, in fact, from here, a very simple and silly contract. Yeah, that's the one. There is a token, and I think like for the workshop theme, which is cold chain monitor, we are presenting like this kind of scenario where perhaps we have a container with some food or something else that you want to sort of monitor the temperature, right? So you would put this kind of sensor into the container, and then it would send the data into Streamr. And Streamr canvases would monitor if the temperature went over some threshold. And once it's done, once it's done means that when the shipment arrives, then the smart contract sends an event saying shipment arrived, and then the canvas sends back a message saying this was how many seconds it was over the temperature, and then the smart contract deducts from the payment to the shipping company. To make a smart contract that is actually like a logistics shipping contract in real life, right? So this is the idea of how Streamr aims to bridge the sort of real world applications to smart contracts. Yeah.
If I'm understanding correctly, the canvas holds the private key, so it can emit transactions when the data stream shows that the temperature.
Yes,
is almost
currently the UI is being reworked, and it's one thing that you will not want to do this with your life savings account, obviously, and the obvious thing is that after you've got the registration done and so on, in order to use the Ethereum modules, yes, you have to give us your private key, and that is silly, of course. We should have it so that it generates these private keys here automatically. But then again, of course, you wouldn't put your life savings account into MetaMask anyway, right? So, so yeah, the way you can sort of start the Ethereum integration with Streamr is that you take, hopefully not that important account, and select from the menu details, I think, export private key, confirm. Now everybody gets to steal my private key. Let's see. No? Yes? Oh, confirm. Okay. So, done. And then this is, well, it's actually that account 3 there already, but test account or whatever. And then private key here. And yeah, well, fair enough. It shows the address. So, now it's available for the Ethereum modules in Streamr. So originally Streamr, well, it has all kinds of integrations, and Ethereum integration was the first, Ethereum integration to Streamr was the first Ethereum thing I worked on, and perhaps I'm not super proud of that soon 2 years later, but but yeah, it is what it is still. We are going to rework that. So, and after you've given your private key to us, then there are modules. Well, we have already written some. We have written some like ready-made cases like this pay-by-use case, and well, I mean it's just code. It can be changed. I can add here some whatever, hit apply, and the constructor parameters will be here to I will sort of, in order to deploy the contract, I would set some recipient address of the coins. Well, this can be anything, it's not used, and there, and then I hit deploy. Okay, alright. I have to also select the Ethereum account that I just made. Try again. So now it sends it to the Rinkeby network. So, I mean, well, you can select different networks from here, but I think Rinkeby is the one that works fine now. So, so yeah, that's Streamr. But okay, let's get back to the programming part. So, since this workshop is not going to be very deep on Ethereum programming in the end, what I probably should go through quickly is the, well, I mean, theory of what those tokens do. So we saw the puzzle contract, well, there's theory of how blockchain works. This is something I would normally explain about the theory of Ethereum before starting the remix. And then the token. So basically, the token is a program that has this kind of line in it, basically saying that the contract keeps track of how many points or tokens or anything the participants have. And well, okay, this is a bit again anachronistic. Nobody wants to build a Bitcoin clone anymore. But still, the point is that yeah, that's how easy, that's how simple it is to count the tokens. Of course, the sort of heavy lifting is what makes the difference. But like the underneath in Ethereum, it's harder to make something scalable than in, well, say UTXO-based systems. But still. The basic functionality is, this is the basic functionality that a smart contract must support so that it can call itself a token. And why is it important that it can call itself a token? Well, since there are wallets and other applications that spend and transfer tokens, this is the interface to those applications. And since in Ethereum everything is kind of typed, but the text-based, the name of the function is the interface, and then the type of the arguments. And well, usually in this workshop, we would build like a token that has some functionality, like UBI token. Every time somebody does a transfer, everybody gets more tokens. Right. So to demonstrate that with tokens you can build in functionality. And then events that go into log are how that's how the communication works to the other way, from the blockchain to the application. So again, ambitious schedule. So we do best kind of coding, which is copy-paste coding, of course. So everybody who got the remix open, they could, well, you can write your own token as well, but you can also get one from GitHub. So so basically this is the interface in the Solidity, explaining the different functions. There's the balances of everybody who is participating, and there's the transfer function that you need to implement. Then there's an advanced feature where you can give allowance, kind of like saying that this contract can spend my tokens, and that's useful when the contract itself, for instance, when we built the marketplace, what the marketplace does is when you buy the product, the Stream subscription, then the marketplace takes those tokens from the buyer's account and moves them, transfers them to the seller's account. So that way the marketplace doesn't have to hold the tokens. And you can basically copy paste this code and change the name of the token and symbol and decimals. And there you have your own token. So where do you copy paste it to? Well, let's go to Remix. Start a new coin. Call it whatever. Perhaps change the name. And hit run, and here before hitting deploy, you might want to check that you have the injected Web3, which means that it will go to the blockchain that is public and not local to the browser environment. So how far have we got? Just sit down for a while.
Yeah.
Okay. Okay.
And do I need to check the version here?
I think that's fine. I think whatever is there is fine. So, yep. There we go. And then maybe change like something visible there, like the token name or something. Okay. Cool. So, why this token? Well, this token in this workshop would be used as the token of exchange for that code chain monitor, which is kind of the more advanced demo or thing to build. That's actually a good idea. Probably should do that too. Yeah. So, hitting deploy. Okay.
I cannot select ERC20.
Oh. See. Oh, that's a good point. Yeah, very good point. So you have to select the correct token. Yeah, that's true. So here you have to select the correct contract and then hit deploy.
I don't have anything in the box.
Yep.
Is it compile?
Right here.
Okay. Or
Yeah.
just to compile first?
Yeah. Well, I mean,
Yes,
yeah, I don't know if it's set on auto compile,
Yeah.
but
Not by default, I don't think.
not by
Because I
default.
just went
Okay.
to Firefox, I hadn't done remixing there before, and I had to pick it.
Oh, fair enough.
That's used to auto compile.
Yeah, it used to auto compile.
But
Yeah.
then you
Just
put in
select
something
my
like
point.
Yeah.
256
That's the choice.
256 and then you freeze your browsers.
Ah.
I've done that
And
before too during the workshop.
MetaMask.
Okay,
Yeah.
nice. So what? 256.
I don't know, just something like a huge calculation.
Oh yeah. It starts doing that.
And
You
Yeah.
have a
it was
zero
it's on auto
Ethereum.
compile.
Yeah,
that's
So
awesome.
during presenting the workshop, it
Yeah, okay.
So you
Hasn't happened to me, but that's
Yeah.
good.
go to get some.
What kind of
I
workshops
don't have
do
a
you do?
Twitter account.
Solidity. I'm actually doing one
That's
tomorrow.
why we do
Okay.
After the workshop
Nice.
space.
Did you put your?
So are you Solidity core dev?
12
Did you put your
Are you
address
Solidity
in the-
core dev? Okay.
Which
Yeah,
was
Solidity developer, IoT as well. So
Yeah, okay. Well, let's have a beer later. But
I think
Uh,
we're in those.
right. Yeah, no. I mean, it's like this is the level that I usually start with. I do this usually with more slowly, but to a bigger audience. So
Yeah. Juuso, is any of your account can still send some ether? He still cannot.
okay.
Because I don't have a Twitter account, so
Oh yeah, no, it's fine. So what's your name?
Dovo.
Dovo?
That's right, yeah.
Absolutely. So
That's your pro mic.
yeah, I mean exactly. You could.
Be generous, yeah.
Yeah.
Yeah,
Yeah, the prices are low now, so I guess I
Maybe
can
not
afford
tomorrow.
this.
That could be 20 grand one day.
Yeah.
Alright. So
10 seconds.
Okay, do I need to redeploy it?
No.
Or it will just show up?
You can click reject.
Reject.
and after it's deployed, we can even check. Like here is this copy button. You can copy the address to the clipboard, and we can even see it in the Etherscan. Yeah. Okay. So it exists in the world. So
Yeah.
this is what it takes to create like a token. Its symbol is J, and I guess here the name doesn't. Oh yeah, my test token shows up here. So basically through that interface, the Etherscan can then read the token information. So after you have to select the test token, and then
So let's see.
and then hit deploy.
Okay, perfect. You need to compile it first. You can do like auto compile.
I think confirm.
So every time you
do it.
change stuff.
And then wait until it gets mined.
Or what?
mine.
You
Oh,
wanna change it?
Rinkeby,
With the
yeah,
fencing.
Rinkeby is a proof of authority, so yeah. Wait until it gets stamped.
Like super token.
Okay, well, on to the cold chain monitor example. This was my. Let's see. Okay, well, we spent an hour on this, well, with the setup and all. So yeah, this is something I have done in 1 hour before in a university setting, and it probably feels pretty fast. and of course, in more corporate setting, it would be better to spend. I mean, originally they started from this kind of naive programmer idea that best way, because there was a lot of interest in what is this Ethereum, what is this blockchain and all that, and naively like what is the best way of describing it, and I thought like showing is better than telling, right? So this kind of hands-on, get your hands dirty workshop for, well, I mean, maybe eventually like managerial people, but like people who would be very interested in the technology, not necessarily technical. And I think like spending a bit more time, it has been, I mean, I've got positive feedback also from people who were not programmers, but of course,
we can leave some time to
yes, but I mean back to the agenda. So that was the token deployment, and the token that I deployed, I could also well, if you could copy paste your token address here. So just for later reference, well, we can then paste that token address into the cold chain contract to cold chain monitor contract to then use that token for this application. So introduction to Streamr. Right. I mean, I'll do that very quickly. So did people register to Streamr.com? Like you've got yours, and
I need to do that.
yeah okay. So I can help with
like
it.
2 seconds.
Yeah, you need an email address. So I'll just try that on this browser. Oh, well, I seem to be logged in this browser as well. So I'll log out. And well, I mean, I copy.
By the way, user speaks Chinese.
A little bit, yeah. It's well enough to check like well, I mean, I do like sometimes the visual check of the pages or the translation. So well, I mean, Wei speaks Chinese too, so he does more. But still, so well, sign up, and you sign up with the email, get an email, and then you're in. Yeah, if I go directly to sign in.
You can use my account.
So
yeah, go to profile, I guess.
So yeah, I mean the profile here, it's below the cogwheel. So
the main thing that you need now to go to profile is to get your API key. There's one default available, or you can create a new one called code chain for this case, I guess.
So this API key basically allows your HTTP request to be identified as yours. So this is kind of from the like Streamr service is a cloud service. Basically, if you want to get sensor data into your DApp, what you need to do nowadays is get an Amazon instance and write some JavaScript, put it running, and have that thing then pull the sensors and send it to the blockchain, and that works, of course. And what Streamr aims to, what Streamr has been already, is basically this kind of a real-time data backend. So instead of writing the JavaScript, you make this canvas and hit run, and then it does the automation for you, right? So that's the world we are coming from. Like this, like we run these things in Amazon for you, but the end sort of goal is to run this thing in a peer-to-peer network, right? So that these automations and more importantly the data stream transport. I mean that happens in a peer-to-peer network then.
Yeah.
So instead of API keys, we are already working on changing that to signing the messages, or that you get the session token by signing a challenge and then use that session token. So
I guess we can move to the next step.
yeah. So in the profile, you can add the Ethereum private key. You can add the API key, and then in the editor, which way is it easiest? I guess it's good to take the IoT part now. So
would you like actually to deploy the smart contract first, so we can do the
sure.
module to inspect?
So the smart contract, again, in the best tradition of copy-paste coding, I have got it in GitHub. So the cold chain monitor contract, and it should be self-contained enough for Remix. Let's see if it is. Again, things I probably should have tested before, but yeah, you know, who has the time? So seems to be good enough for Solidity or for Remix. I mean, I developed it. Yeah. Let's take that away. So to deploy this thing, this is kind of continuation to the previous exercise with the token. So there's a couple things. So maybe I should wait for people to get to this point. So I chose the Run tab, and then chose the cold chain monitor contract, and then the deploy has all these parameters. Well, I could.
Excuse me?
Yeah.
Could you show the what I have to write in the profile settings again, please?
Absolutely.
Yeah.
So the profile page was.
Yeah.
You can write here anything basically.
Okay.
Like the key name. It's just like name for the key. And hit plus, so it will generate a new key. So the key is essentially just a bunch of base 64 or something, and by attaching that key into the, let's see, like attaching that key as authentication header will then mean that you can make these API calls as well, Waylay, for instance. And this Ethereum private key thing was that you give some name to the key and then paste the private key you get from MetaMask.
Okay.
And then hit plus, so it will add the account. I mean, if I would have some 1, 2, 3, 4, well, that address would be like this. So yeah, the cold chain monitor contract, I could do a very brief walkthrough what it is. It has this thing here, again the ERC20 interface. It has events for order accepted when some shipping company accepts the order that has been put out, and this cold chain monitor actually represents one order, one shipping transaction. And it takes in all these parameters, saves them basically, and then when the order is accepted, it will transfer tokens from the customer to this contract. So this contract will be an escrow for the payment. So it will take from the customer payment tokens. It will also take this kind of stake from the service provider, just so the service provider has, well, cannot just accept contracts for fun. And then when the shipment arrives, well, yeah, here's like in case internet or stuff wouldn't have been working here. When the shipment arrives, it will send the shipment arrived event, do really nothing else. The customer is allowed to say that now the shipment has arrived, and then the canvas should call this payout event with the sum of seconds that the temperature was over the limit. And then there is some time penalty for missing the deadline, and then there's some deduction for the temperature penalty. Stuff like that. So this is kind of the scenario. It's somewhat involved, but and finally, those who were involved in this transaction, they can withdraw their funds in the end with this withdrawal method. So yeah, I mean, this kind of thing, and yeah, so what is required for this contract to materialize? Well, we have the token address. So I had my Juuso token. I think might have been yeah, 9C5. Just to check. We have the canvas address. So canvas address is basically the address that the canvas says who is. So it is the Ethereum private key that we just added, or the account, or the integration account. So I got the, well, I mean, see, did I? Yeah. So I copied the address. Well, I can also copy it from the MetaMask where I got it from, etc.
Can you show them again in case they didn't integrate it?
Yeah, absolutely. So the MetaMask, if I want to integrate with the Streamr, so for instance, I'll take this. For instance, this account 3. Go through this hamburger menu and hit on the details, and from here I can export the private key. So that's the.
Quick question: why would we need a canvas address for this account?
Well, that's the integration from the smart contract to the blockchain. So the smart contract can only send the Ethereum transactions with some key. So you cannot send transactions without signing them, and the signing key has to come from somewhere, and we should probably auto-generate them. And so, but of course, it's also convenient that you can get the accounts from somewhere else, because then you can use the same accounts in something like MetaMask and also Streamr.
So it's basically setting an owner.
Yeah, basically you are handing over to us the private key. So we put it in a database, of course, encrypted and so on, but you wouldn't give any very valuable private key. In MetaMask, of course, the good thing is that these accounts are free. In MetaMask you can say create account, and it will create you a new account.
Yeah.
And that's it.
Like a normal scenario, consider almost as a not your private bank account, but escrow account.
Or a throwaway account.
Yeah, like a temporary, account, like temporary credit card. So if anything happens to that, you only lose whatever you put in that, and not your entire.
But I mean, for sure, yeah. I mean, again, but it's kind of, if you give some platform the right to sign Ethereum requests from you, then you are essentially giving them your private keys, and that's what it is.
Yeah.
But of course, it would be better that we would generate a private key and then hand it the other way around. Yeah.
That's how a lot of exchanges do, right? When that.
Well, they don't give the private keys often. That's the thing, that exchanges often keep the private keys, and they never even give them to you.
Yeah. So you have even less control. But yeah, that's how.
I mean, we still want to give the control to the user.
So okay. Does everyone have their canvas key? Oh, those are at least trying to find. I guess we can deploy.
Where do we find the canvas address again?
Yeah, what's the
Oh, this is the address.
Yeah, the canvas address is the address that you use for the private key here. So for instance, if I I mean that's the address that the canvas is using to sign them.
I see.
So ideally it's not like your address, but it's the canvas integration address, the throwaway address that you will never ever use anywhere else.
Which node should I put into the canvas to start sending transactions to the network?
I think you mean those modules, yeah? Yeah. Okay. So how it works is that, well, we have some existing modules here, like this pay by use thing, and well, I think I just did this thing.
Yeah,
Well,
it
I
just
mean,
show.
well, okay. I just make a new one. So we have something called Solidity Module here. Super old Solidity. Sorry about that. The compiler is super old. So it starts with making just some contract like this, and it is still in the time where constructors were with in the Java style, and of course if I hit apply to this code, then I get this argument there, and yeah, I mean this we could put that code like the call chain contract through here as well, but let's see if I do the I mean we can do it like that, and well, let's just write some function there as well for testing fun. So again, something like that. Then there is another module called Ethereum call, and as soon as this thing is deployed, then this contract can be called. Well, if there would be more functions, you will select the. Can you actually see this thing at all? So you can select the function to call, and then from somewhere else you would get like the values for the arguments. So this is the sort of calling those smart contracts the way that works. And as for the call chain contract, well, I'll deploy it first. So I'll get my canvas address, put some temperature limit there. Well, 10, I don't know, or maybe 30. Deadline timestamp. Oh well, just put something big there because maybe I don't need that feature now. Payment token. Payment. Well, just put 100. We can hopefully make more of those tokens anytime. Temperature penalty.
25. Oh.
Yeah. Well, yeah. Okay. So there was some values that we could overtime penalty. Okay. So sending this thing to the blockchain. The way I get this contract then into the Streamr canvas. Well, I mean, if it's verified in Etherscan, then it can fetch the ABI from Etherscan. But yeah, since this thing is not, then what I can do is remove that thing, and instead there's like a module called get contract at. So I put the address here. It doesn't find the ABI, which is the interface for using that contract, but that we can get from I think we can get it from here. And compile tab and detail. Well, here is even a button for copying the ABI. So I copy that ABI in here, and then the contract. Oh, it's still the Ethereum call module for sure. And this is how we can use the existing contracts. So I've got the different. If it still is visible or not. So we can use the existing contracts like that. So we have these different functions over here. And for instance, if we call a function that doesn't require transaction, then we just give. For instance, let's ask what is the token address? Okay, so it's basically a function that returns the token address. And well, put the button to trigger that thing because it doesn't have any arguments. So on Streamr canvases, all these modules are sort of triggered by some messages that come in. It's all about automating this kind of data streams, right? So for instance, this module doesn't have now any, well, it doesn't have any way to trigger it other than artificially like adding a trigger button. But usually, like for instance, if there is a stream module and it sends a data point, it will activate all the modules where it goes, like that process that data point and then do something with it. So it's basically building these kind of pipelines of automation. But now I'm just going to add a button for activating that module. Oh yeah, this is also a good feature to explain. So we have like again from the trading background. So building the algorithmic trading algorithms, it was very important that you could backtest your algorithms for using historical data. So you build an algorithm and then test on historical data if that makes any profit, and if it makes a profit that you can believe in, then you hit the change it to real time and hit start, and then it will start doing its thing. But here we of course are mostly concerned with the real-time case. So I'll just give it some name. Test. No. Okay. So and to see what comes out, put like a table here. So if there are errors or if the actual address comes out. So what this Ethereum call module does is it goes into the interface definition, which is this ABI, and checks that okay, it doesn't take any arguments, but it returns an address. It doesn't, again, the module doesn't tell what the name of this doesn't have any name, but it's just a type of address. So since it's not named, we just show the type. And then hit start and see what happens, if anything happens. And hitting that button, it will, well, I mean this was kind of a trivial example of course, but it will go and call this function in the smart contract. And if we look at the actual smart contract, then the only thing that it did was call this call a function generated by the public keyword here. So kind of simple, but I mean in the same way it can send the transactions that are now signed by the test account here.
Did you build on some existing framework for this tooling, or is it all your own work?
Well, those, when you contact these things, it's JS Plum. It's like this kind of JavaScript library to draw these arrows and stuff. But I mean, all that you see here is it's old things that we had already when we started this ICO thing, right? So this used to be an internal tool for traders, and yeah, the story actually starts from that what became Streamr was a trading shop, just people trading stocks and whatever. And they needed, they wanted to experiment in algorithmic trading, so they hired a person to create this thing. And it was pretty agile developed, I guess. So it's already being reworked. All of that is jQuery. So it's being reworked into a well, React application and all fancy stuff like that. So yeah, it is self-built, and the framework that we use. I mean, we run all of these things behind the scenes in Java. So all of these modules, each one of these corresponds to a Java class. So the Ethereum call is a Java class called Ethereum call, and with a little bit of magic of reflection, it will sort of get, well, no, actually they are even in database, no reflection there. But still, the thing is that they are Java classes behind the scenes, and this is sort of just the wiring, how you wire those classes together, and when you hit play, it will send that to the server, and the server will run these automations and send the UI events back in WebSocket. So for instance, this is a WebSocket thing. So so this button widget, these are web components, so I can take this button and put it on my website or whatever, and it will work the same, well, hopefully. And then it talks to the server with WebSockets. And same with this table, like the server sends the WebSocket, through WebSocket, the new rows that you add to the table. So, I mean, that's the sort of backend thing that we have, the Streamr engine. But yeah.
Okay, I wanna do the, I guess, root sensor.
So we got this far. Hopefully those who were new to Ethereum development got something out of it. So kind of the idea that it's not super scary. Like, of course, the cold chain monitor example is still a bit of a toy example, and well, on my plane flight here, I didn't have anything better to do, so I wrote the cold chain monitor example, but also the more real-world example where you, I mean, it was a 3-hour plane flight, so I also wrote tests to it and everything. So so here's like the GitHub. So basically the monitor itself is kind of simple, because for each shipping container that you send out, you would have to instantiate a new contract, and that's not cool. You would have some kind of order IDs, and you would like place orders, they would get order IDs, and then every function would additionally take an order ID. So, and in kind of like real world Solidity development, you would also write tests for sure to make sure that they work. And this, I only wrote the happy path test here, but of course you would test other cases too. But the happy path is basically, well, actually this is a good way to demonstrate the scenario as well. So shipping process, we set some of those parameters. All parties give necessary allowance to the contract. So they say that okay, this shipping monitor contract can take from customer and service provider the necessary amounts of tokens to pay for the service. Customer places the order. Shipping company accepts the order. And again, like there was a good talk here just a while ago on Web3. So this is using the Web3 classes like JavaScript objects for talking to the contract. So shipping company accepts the order. Order is in transit, goes over the temperature for 200 seconds. Customer receives the order, and Canvas reports then these overages. So there are deductions that the Canvas must calculate. So this would be done with the Streamr Canvas, and then shipping company withdraws the payment. The monitor well, basically the Canvas also sends this monitor payout call, and then when it gets the shipment arrived event, and then the shipping company withdraws its payment. We check that yes, they got more money, and customer withdraws the deductions for the temperature transgressions, and we check that that goes out. And yeah, when I run that, it passes. Yeah. But I mean, yeah. So this is what like real world smart contract development would probably look like. Yeah. So this was my Ethereum introduction, and I give the stage to Waylay.
Yeah.
For this will be good.
Yeah. So I mean, my part will probably be brief. So what user demonstrated was first of all, I mean, the basic components of a smart contract, how you can deploy, you know, all different scenarios and take arguments from, I guess, the real world. Usually they call that Oracle, right? Like some kind of outside real world knowledge system. The question is because Ethereum or most public blockchain have a lot of throughput issues. I mean, like Ethereum, what are we, like 15 transactions per second, and Bitcoin, what, like around 7, I guess, 15, 20, 15. You cannot, like, we got sensors that sense probably like, you know, tens or hundreds or like, you know, thousands of data points per second. So you cannot really just push or like shove those data sensors into a smart contract, because you end up paying probably like $100,000 per day on gas fee. So what we are going to demonstrate is actually, you know, using like a gateway like a Raspberry Pi for easy integration by getting data sensors from the Ruby tag which, if you guys are not aware, so Ruby is an open source hardware company, right? They deploy like Bluetooth, low Bluetooth beacon sensors, self-contained weather stations. So they emit data about temperature, humidity.
Pass it around.
Yeah, I will keep one and pass one. If you open it.
There we go. Oh. You can put it in there. Or actually, maybe it's fine without.
And so yeah, what we are going to do is show you how we can get those sensor data, use Raspberry Pi as a gateway to push the data into a stream, like Streamr, just like, you know, an easy way you can push real-time data, do your aggregation or like, you know, any I guess transformation, data processing that you need. And then once a certain events that you set as a trigger happens, then that is when, you know, the specific module will trigger the smart contract with the required argument. And so, you know, you actually trigger once or twice, and you know, 100 times. So I think we got the working internet. So what I'm going to put here is actually SSH IP address that you can actually SSH into the Raspberry Pi, push the data into your own stream on your Streamr account, and so while we push our own stream of, you know, temperature sensors into our smart contract, you can do the same with, you know, varying parameters and stuff. So 10.
I can write it here.
Of course, you have to use SSH for temperature. User is a pi, and then password is 1, 2, 3, 4, 5, 6. Well, easy to hack. So what happens when you push that one into it? Do you have an SSH terminal?
You just do it from terminal.
Okay, I'm a Windows guy, so actually.
Yeah, what do the Windows guys do?
So
we use PuTTY.
Oh, okay, put it.
I mean, I like PuTTY.
put it tray, I think. It's been a while since I used Windows, but
Yeah.
so
Pi.
1, 2, 3, 4, 5, 6.
Yeah. Perfect.
So,
So,
I don't know. Maybe
Desktop.
actually this
Huh?
this kind of Quake terminal is maybe not the best. Just try to make it a little bit bigger.
Okay.
Or Command Shift Plus.
Command Shift Plus. Unless I have overridden it somehow.
Oh, your keyboard maybe.
Your keyboard mapping is.
Oh yeah. Oh, there we go.
And then you gotta reset.
Yeah. On my laptop, I have like a 3 language keyboards, and that always gets screwed. Like. Okay. So once you SSH in, of course, let's do the shortcut. Going to desktop, and you will see a Ruby folder, right? What we have in there is actually you can say a JavaScript file called streamr.js. I installed Node.js on this Raspberry Pi, which is pretty forward and I guess pretty straightforward. And then what you need once you have a Node.js ready, just like install the Ruby Streamr module.
Yeah, npm package, right?
Yes, is an npm package. Which let me show you. Let's see where it's available. Ruby Streamr. in case you want more info. And I mean, all you need to do is npm install Ruby Streamr, of course, and this is like example of the streamr.js file that you need to create. All it asks you is your account API key. That's the reason why we ask you to create your account to get your API. And what you see here is just the tag ID of the Ruby sensor and the name that you wanna give to your stream that gets created. Because actually using the API key creates the stream automatically for you. Because on normal scenario you have to create your stream, get your stream ID and API and the push data there, right? This is just like a ready-made integration. Of course, the Streamr has its own JavaScript library that you can do vanilla integration.
Streamr client.
Yeah, Streamr client. Sorry. I guess I can. Do we have a Streamr dev? Okay, here. And you know, creating a stream instance, subscribing to real-time data, it takes only a few rows, and I guess producing data to a stream is only like pretty simple. So what you can do actually, if you wanna follow the step, is just do a copy of the Ruby folder. So that's how you can copy the Ruby folder into your name. Use your name underscore Ruby if you want. So if I were to copy, probably it's like
cp-r. Or I don't know if that's required.
Yeah, that's sure.
That's
keyboard.
yes, keyboard.
Ruby, and then probably it's like way Ruby, whatever. And once you are done with that, all you need to do is actually edit the streamer.js.
No, but you could show that, I think. Like, do the copy.
Oh, okay. It's like playing a mental puzzle with all the keyboard marking. Okay. No, doesn't. Someone didn't use underscore. Oops.
Yeah, doesn't matter.
Just kidding. Okay. Do I have mine? Wait. Streamer.js. That's easy peasy. The two tag ID that I put here are exactly the two Ruby tag sensor that we're passing around. Change the API key, and the way you can get your API key is go back to your Stream account, go into your profile.
It's a session right now.
Yeah, you have a Firefox, right? With my account.
Yeah, I have that.
Okay, let's see for mine, because it's actually pushing to mine. Anyway. Okay, you can create a new one, or you can just copy, one of the default one that you have.
They are all equivalent in the. I mean,
Yeah.
why you can create many is that you can revoke them then.
So when you
create one for each.
yeah, when you go to streams, you can see if you have already existing one. So, for example, I have there's two streams that right now I have this data that got pushed earlier, but there's nothing going on. Oh, maybe there is. Yeah, actually I'm already pushing to my stream. So as you can see, this is real-time data coming in of the sensor. If you don't have that, of course, don't worry about it, because once you paste into the your API key and your
his computer is upstairs, so it's still in the same network, I guess. So.
No, I think I started pushing within this Raspberry Pi already.
Oh yeah, exactly. Like, you'll probably open in a shell window in your computer.
Now, all you need to do is once you have your API key done and saved.
Do you need to?
Yeah, the library actually gives you like a warning if you don't. So, and you know, if on two tags is pushing data to the stream, and if you did correctly, even if you didn't have the two string called Ruby and Ruby 2, these module should create the string for you. And once you go back to the stream, you should be able to see this two with real-time data coming in. And you know, now instead of having a physical button triggering an event, we can actually start getting our Ruby 2 string. Actually, maybe I should. I can show it separate. So this is stream. We can stop the real time. Now, just to see if we are getting like real-time data into the stream, let's get a quick table. Let's get the temperature, which is all we care about, and see if anything comes out of it. Okay, perfect. So as you can see, we have timestamp and temperature coming in is 23 degrees Celsius. The one that you are passing around is the Ruby one. I have in my hand the Ruby 2, so let's see. As you can see, the temperature is decreasing. To reach 24 soon. Okay, there you go. Real-time sensor temperature into the stream. Now that we have the real-time temperature, we want to do some sort of you know, aggregation or like calculation logic. Mean like we want to put a threshold on the temperature that you know, above which if the cold chain logistic hits, you know, there should be some deduction or penalty on the smart contract at the end of the transport. So that is how we start gluing the sensor with the smart contract side. So I have a canvas that's called Overage accumulator, and I think that one we need to share with everyone, like the link, right?
Is there a way of seeing from the Streamr.js, like from the Raspberry Pi side, if it's pushing data? Like, will it say?
Yes, there was. I think I might commented out the print, but yeah, inside the node module, you could actually print the output.
Those are both.
Okay, for the overage accumulator user, do we have the link in the Google Doc for people to save on their own?
Right. So, one thing that you can do with Streamr, at least, still, as nobody has completely abused that functionality yet, so we haven't been forced to shut it down. So if there's some integration module that isn't there, of course this is an open source project, it's all in GitHub, so you can write your own modules in Java. But for a bit more rapid prototyping, it's possible to write your modules in Java on the canvas. So we also support JavaScript, I think. But yeah, so on the worksheet, specifically for this workshop. I think I wrote like this kind of canvas that does the overage accumulation. So basically, what this thing does, Java code in here. So again, slightly bigger. So what it does is it has all these inputs defined and output and a parameter. What's the difference between input and parameter is that you can type in the parameter in the canvas, and it's kind of similar as the constructor parameter that it gets. The canvas gets the parameter when you start the module gets the parameter when you start the whole thing. Then there's some internal state. There's the initialize the sum to be 0. Well, I guess that's what it would be anyway. But and then there's the send output function, which well, I mean, it's called whenever the module is activated. It's supposed to produce some kind of output. So you get the values from the inputs. There's a reset input just so you can reset the counter. Then it calculates the difference between the input value and threshold value, and if it's greater than 0, which means that the temperature is now over the threshold, then it starts accumulating the sum. It's a very simple integration. Step integration. You take the time difference and you take the temperature overage, and that's it. And then you send out. Then it sends out the through the output result. And from the worksheet you can open this thing, and you can type, click here to save as to save it for yourselves. So I had shared this canvas, but you can check that the share. You can check from the share button that it's yours now. You have the access right to it.
Yeah.
So that's this kind of Google Docs style sharing feature. But
How do we access the overage?
I think from the worksheet, like look at the Google Doc thing.
Yeah, so
I think I had the link there.
So Google Doc, click on the Overage accumulator canvas if you want. So once you open that and you're still logged in on Streamr, you can save as your own canvas, and then on the add the Streamr module, you can select.
Save it with the same name. Yeah, or you can change the name. Click OK. Even if it's on the same name, it doesn't matter because it will go under your user account, so it's still different. The names are just strings.
Yeah.
But
so what? Yeah.
Oh yeah. The way that you actually use it then, like once you have it saved as, then
canvas.
Then you can click on the new canvas, like left upper corner, like the blank paper.
Yeah, this one.
Icon. Yeah, new canvas, and then in order to use that.
Yeah, you type canvas.
Or from the add stream module, or you can type directly on the canvas like this.
Mm-hmm.
So this means that you can take this kind of sub canvas. It's just to you can sort of package these modules together and then export some outputs and inputs, and they become like sub canvases. Like you can build do this kind of building blocks.
So you could drag temperatures into values. Threshold we can put like 24 degrees, and then we can add a table as output, I guess.
Yeah, this table is good.
Yeah.
But actually chart is good for that.
Yeah, we can do both. That's or chart.
And the overage accumulator. I've got a new canvas. I'm just not sure how to add that.
Oh, sorry. So that's a module called Canvas.
It is.
It's kind of like Yo-Dog. So I heard you like.
Did you connect the overage sum to the table and chart?
Yes.
To both?
Yes.
Okay.
You can connect to multiple if you want. So, I mean, the reason why C is stepping up is because already actually 24 degrees.
Okay. Yeah. Okay. So fair enough.
Okay, we can do the.
Try again with some other number.
Yeah, we can do like 25. And we can add the extra table here.
Oh, you got that.
To see what is the temperature.
I should also visit the back rows, but that's why I asked people to move in the front, because then I can do. Because this is supposed to be a workshop. Hooray!
See,
yeah.
like
No, it's
once
good,
you
yeah.
put like threshold that the temperature is not heating because the current one is 24.3, the overage accumulator doesn't do anything. Is a 0 and keeps in 0. But as soon as let's see,
Maybe it's the other sensor though.
no, it's this one is increasing.
Oh, it is.
Yeah, so 24.9
Oh.
and 25, and now it starts like slowly accumulating. So what this value accumulation means is like you can put a certain time multiplied by specific, let's say, weight or value amount to accumulate what the deduction could be on your contract, right? And that the contract is set between the client and the supplier at that point. And let's see if it goes down. And then what happens is it stops accumulating. It goes below 25 degrees at a certain point. But we can probably. And then at the end of the, I guess, trip, when the client receives the package, the event like package received can be triggered, and this output of overage accumulation output can be sent into the smart contract as like finalized. I guess I don't know what you call it. I guess penalty amount settlement, and. This doesn't want to go down anymore. Probably should put like probably 26 for safety. So this starts tying back the idea. Okay, how you can get like a real-time data sensor into like a stream, do number calculation, aggregation, threshold, and then deploy like event into a smart contract to get I guess like whatever automatic trigger segment. User,
Yeah.
so here's set or connected. Do you want to do the final connection to the smart contract?
I haven't faced the correct API key.
Doesn't want to go down the temperature.
Yeah. So now we have like accumulated some kind of overage here, and of course we are kind of like still within the time bounds. Whoa.
Yeah.
Well, I have to find out something else to talk about. No,
Wow, we can push.
No, of course we do still the grande finale, which is of course getting it somehow connected to the
smart contract.
smart contract and seeing if that.
And waiting for it to go below 25.
Well, yes. So the smart contract, the way it looked. Let's take this a little bit smaller again. So the way it looked was, let's take another window here. Just,
Well, that one.
oh,
Is portable.
perfect. So yeah. So open the. Yeah.
I was just gonna get some hot debugging related to
Yeah, I can
Yeah,
tell.
okay.
Yeah,
So,
I'm going to need help too.
Yeah, of course. And so there was this canvas set up already with the smart contract, right? So basically what we wanted to do was trigger the smart contract when the shipment arrived. Yes, I think that was one of the things. But what we want to send the Ethereum call for, or the Ethereum transaction for, was the payout, right? So so there's the overage sum, and what we can do, well, I guess I might as well take these things to the other kinds. I mean, what I can do is here again export this thing and make it like a sub canvas, but I might as well move over to where I was, which is this. So this is already running fine, but let's stop it for a while and add here the contract that was deployed earlier. So, well, I'm going to do this a little bit fast now, but I can definitely help with that. So once we have the contract, we can listen to its events. So we have this kind of get events module. So we listen to the events. It basically works like this data stream that whenever an event comes into that contract, it will start activating modules that start off from this get events module. So when shipment arrives, basically we want to send the, I guess we want to send the overage sum back to the smart contract. So what happens here is we can take this kind of sample if module, what it's called, and we trigger it if we got shipment arrived. And the value that we sample from that time point is the value produced by the overages. Then we take an Ethereum call module and connect that to the contract, and this whole beautiful thing, of course we select here the payout, and the overage sum is what we get out. So this sort of setup, basically, again, walking through it module by module, is that once we got this overage sums from over there, we get the contract at this address with this interface. We get the event when the shipment arrives, and then when the shipment arrives, we sample the current value of the overage accumulator and send that to the smart contract. So this is like the typical way you would build this kind of integration automation with the real world data to the smart contract. So you've got the real world data coming in, and you've got the smart contract hooked up here, and then you push the real world data. Just one point of data, you push that to the smart contract. And that's how you make the real world data sort of manageable to the smart contracts. So basically building this sort of oracles. And that's sort of the, that's the way Streamr is also an IoT and blockchain platform. So I have to revise what I actually wrote in the smart contract. I guess since the smart contract was now deployed, well, we have to still do quite a lot of things to get the. Yeah, I guess I made it a little bit too complex. Well, it was a long play palette, but I'll have to still give the token these allowances. So I'll go back to Remix where the coin was. this thing, and well, I guess this is one place where I can do those things. So let's see, the cold chain monitor contract. I probably have to accept the order, right? So I'll select another account that I have. Let's say account 1 will be now the, well, let's say account 3 is the customer. Oh no, account 1 will be the service provider, right? So I select account 1 and I call the accept order, I think, right here. Oh. Why will it fail? Oh yeah, yeah. Well, that was what I was supposed to be doing. So, giving the allowances. So first I have to approve that this contract, cold chain monitor, can spend my tokens. So I say spender that much tokens, spend as much as you want. Send that transaction. Confirm. There was some warning there. Oh well, I hope that doesn't ruin the show. Then for the customer, I have to do the same thing here. So I go again to the coin and say approve spending. Oh yeah. By approving this action, you get grant permission for this contract to spend up to that many of your J. Right.
Is that enough tokens?
Yeah.
Because it's 18 decimal places.
Oh, it's 18 decimals. Yeah.
You need a big number.
Yeah, that's the funny thing with Ethereum often is that it doesn't have floating point numbers. So it has these fixed point decimals. And fixed point decimal is really old school because like 20 years ago when people didn't have floating point units in the computers, well, I guess I'm just about old enough to have lived that time. So fixed point basically means that you only have integers, but you're saying, okay, it's actually a floating point number. It's actually a decimal number of 18 decimals. So yeah, it's still a big number. Good point. I'll have to redo the approvals for this guy as well. Sometimes you have to refresh the page to make things work. Okay, let's see if the shipping company, which is shipping company doesn't have much ether, but they can accept the order. No, they can't. Oh well. Who would have thought the demo failed on overly complex code? Well, okay, let's see that all the other parameters are roughly there. It's actually not a bad tool for debugging things. I mean, Remix is kind of that's one thing about the Ethereum tooling ecosystem is that since Ethereum is quite new, all these tools that you can use for development, well, I mean, this is useful sometimes for simple contracts because you can do time travel debugging here. That's pretty cool. Like when you can look at the transaction, why did it fail? You can look and go back and forth in time. So that's pretty cool with Remix. That's actually a feature that every IDE everywhere should have. But yeah, of course, Ethereum is simple enough for that. So. Yeah, I mean, I haven't prepared this demo so far very well, it seems, but let's try again. Now I have got the. Let's see if I try to ask the is ready. Oh, but is ready says true, so it says I have the requisite token allowance, but for some reason this require is still failing. Maybe the customer and the service provider don't have enough. Oh, they don't have enough tokens. They haven't got any tokens yet. That's right. So, fair enough. So who was the token owner again? Token. Oh yeah, I guess this is free for all. Anyone can mint. That's great. That's very democratic. So so let's just mint a couple tokens. Let's take that out. There's still like 14 minutes. I can't believe it. I thought this would be complete time disaster.
So if you ever feel frustrated about coding, you can always mint a few billion tokens for yourself.
Yeah, exactly. I mean, why not? So
Just brag to friends.
Yeah, and like I made a weight token.
well, I mean, now you have your own token, so I mean, you can do whatever you want with it. Well, yeah, because this particular smart contract is well, actually, this is not even owned by anyone. This is pretty anarchistic. But okay, so now let's see again. So this ready is still true. Accept order. I want to use the account that has less. Oh, what's this thing? Let's confirm that. So I wanted to use this account for accepting the order. Oh well. Let's see the balances. Balance of that guy is large. Balance of this guy is large as well. So what's the problem now? Yeah, this is like for the experienced Solidity developers debugging challenge. Oh well. Let's see if I can do it with this. No. Maybe I should just, I mean, go radical and remove this requires. The payment itself is. I haven't made them public. Oh well. Yeah. We should have. So yeah, sometimes I could actually. Yeah. Well, why not even show the now that I wrote an overly complex contract for this workshop, I might as well show the great feature of time travel debugging to see why this thing doesn't work. So I will need the JavaScript VM and I will need to deploy. I mean, right now it seems for the workshop, for the purposes of the workshop, I wrote all too fancy contract. Embarrassing, but that can happen, I guess.
Yeah, that's what they say.
Yeah.
If you write as my contract for your own project and do ICO, make sure it is audited.
Audited, yeah. Yeah, I mean, it wasn't enough to write the unit tests, it seems. Let's see.
Because once something is locked, not even Vitalik can help you.
Well, yeah, not anymore. Not at this time and day. So okay,
for testing, of course.
Yeah. Okay, so I'll just redeploy that thing because, yeah. So again, token address I get it from my cool coin. Canvas address I get it from the canvas. Yep. So this one. Temperature limit I set to 24, I guess. I'll transfer something large. Is there already the next presenter waiting to set up things, or is there an expert? I mean, there should be an next presenter.
We still have
I know. We were waiting here like 10 minutes before at least. Will we have time to set up? But I guess we do. So yeah.
So the idea is that the user that deploys cold chain monitor happens to be the same user we're using inside the canvas? Because
Right now, oh yeah, it becomes the customer.
It's also the customer.
Yeah, because the customer, well, yeah, in this very simplistic version where you would deploy a new contract for each shipment, which is, well, I mean, if what your ship, well, I mean, it's probably not that expensive actually. But fair enough. So I've got a new one here. I'll have to give the allowances again. So spender is now this contract. And well, for the next, you could say that this was a bit of a pilot workshop in the sense that I've done lots of these simple workshops where we get people to play around with the tokens and deploy their own token and then exchange them with the wallets interactively, this kind of. But integrating that with Streamr was, as I said, I wrote it in the airplane.
It was handy SSH into the Pi. That was handy just
That's fun.
Yeah, to get a
have
sense.
that there ready.
Yeah.
Yeah, and you got the data to the Streamr canvas, so it's like it's kind. It's embarrassing that it is my overly complex smart contract that rules the workshop.
But yeah, it's actually the idea is like if you can do with a Raspberry Pi any sensor, then you can do actually with 90% of sensor in the world, right? As long as you have internet connection or I guess gateway.
That's normally the challenging part. Like this complexity here is more so just about the token complexity and interacting with the neat rings. That's sort of no fault of anyone's there, but the rest of the core part of it is actually
Yeah, and I mean, it's supposed to be simple to get your sensor data in. That's kind of it's actually like the sensor manufacturer that wants that part.
Yeah.
Right. So we support this kind of environment sensors as well, like the smart citizen sensor, which is like pollution and all that sort of things. There are the cases that there are governments out there that don't want pollution numbers or unofficial pollution numbers to come out. So the smart citizen sensor kit is also like an open source hardware kind of thing that you can build. And they sell those ready-made as well, assembled, but I guess like quite cheaply. Like the parts themselves are cheap, and then like again the Streamr could be this kind of decentralized platform to distribute those unofficial sensor readings.
Yeah. You can just have a divisor that they apply to the pollution. In certain countries they just divide it by the country.
Yeah, exactly. You can use Streamr Canvas for that.
Yeah. Actually, one potential pilot.
Yeah, exactly.
One of the potential pilot project was like for communities to deploy, for example, a sensor where they'll send the data to a streamer, like one stream, and via the data marketplace, people could, not people to do the I guess integration, but like app could integrate. So people can pay, for example, $1 per month, right, to get the local area, I guess, pollution level. So then, because the payment are set automatically, they could actually get a fund to sustain their own community sensor over time as a maintenance and stuff. So much more like community-driven project.
And if you're able to reward quality of data, like uptime, for example, if that's incentivized, that'll be more likely to maintain since it's more accurate, like
absolutely, and I mean right now the marketplace is a bit of a proof concept, right? It's like the first iteration. It's quite nice, like as for UI, we've got real designers designing it and all that, and those same designers are going to do the revamp on the. So
the marketplace is individuals.
No, streams of data. So I guess a core product that we're launching is called the community bundling. So we're doing some pilot. Imagine like 100,000 Fitbit data all streaming to like one data stream where data buyers could be health centers with that they can subscribe.
Well, I mean, I can show the product creation as well. Like create a product, and then like.
This would be, for example, agricultural weighbridge.
Yeah. I mean, again, like we are very unopinionated on what the stream data is. It can be text. And numbers. I mean, it could be like often we get the question, streamer, is it like streaming video? Our founders often say, like the management says, yeah, that's not ruled out. So yeah, but I mean, of course, this is not geared for that sort of thing.
So yeah, anyone with a data stream that could create a product, set the price, is like there's a smart contract deployed.
So I can now sell these Ruby streams. I can select like I could set some. MetaMask is not installed, but anyhow, so I could put those streams now into a product, and then this product would select the cover image because this is. So that was actually a good picture for this product. So no, publish, right?
Yeah. Now you need.
Oh yeah, I have all the rights to publish the data. That's also kind of important. But again, our marketplace will not make much more effort than this to actually make sure that. So that's.
Yeah. So I mean, the core. I guess the core product would be like actually the network pub sub system, easy integration to push like IoT data into a stream with potential trigger integration with smart contract. So the what you saw before, the visual editor, like the drag and drop Visual BI editor, or the marketplace actually are use cases that can be implemented on top of the network.
And then yeah, I mean one more thing that's worth showing is that if I now go to the other user and this is now different user logged in. So if I look for that Waylay Ruby, I can like purchase it, and now it's a free product. So
actually, you can purchase and show like in real time. It takes like 5 seconds.
Yeah.
So but then you can add it to editor now.
Yeah. So I click on this, and then it jumps to the editor, and I can start building stuff on it. So
connect to the table.
So I mean, we kind of want to make it easy to build these data backends for dApps. So that's our offering. But the core offering is going to be like a core infrastructural contribution that we raised the ICO for, etc. It's going to be the peer-to-peer network for actually delivering these data streams. So right now it's all in Amazon running on Apache Kafka, but we want to sort of build a decentralized Kafka. So the difference to IPFS is basically IPFS is a store and retrieval thing, and ours is going to be more like PubSub. So we want to optimize for low latencies, that sort of thing. Kind of BitTorrent, but we want the latency and not. I mean, bandwidth is kind of secondary. Sort of thing. Okay. Yeah.
One last question. Do you plan to build on top of some existing peer-to-peer infrastructure, or you're going to deploy your own protocol?
Yeah, I mean, we started building a proto on the libp2p that IPFS is using. We've been looking at WebRTC, that sort of things that are already existing, like P2P networks for this sort of thing. So yeah, we try to invent our own as little as possible, but then again, like in the end, when there's going to be several of these, the one who has the sort of lowest latencies, etc., is probably going to win. So we try to be as good as our core sort of history, you could say, core competence historically is the sort of low latency data automation. Like you can think the automated trading algorithms that you leave running and then they buy and sell some financial products on the market. So that's kind of the one of the sort of design goals that we want to be good at. So delivering this sort of blazing fast real-time data automation thing. So thank you very much, and